In this lesson, we'll try to see what is free body diagram and how it is used in engineering mechanics. To begin with, consider a system consisting of three objects as shown here, touching each other. Okay. Let me quickly label them. Let us say this is object 1, this is object 2, and this is object 3. Okay. Typically in practical system there may be more number of objects in a given system, but take a simple case here. Okay. There are several things you might ask. Let us say these bodies are touching at 3 points. Let us say one point here, another point here, and another point here. We might ask questions such as, what is the force exerted by object 1 on object 2 acting at this point? Okay. Or we might say, what is the maximum weight of this object 1 so that these objects 2 and 3 are not separated? You know, if you have two rollers on the top of which you pile a third one, the two rollers may get separated. Or we might say, what is the maximum coefficient of friction at these points so that you'll have equilibrium, sustained equilibrium existing. Such questions can be answered if we try to concentrate on each object or subgroup of objects within that system. Let us say we try to focus on object 1. We'll try to draw object 1. Okay. And see what are all the forces that are external to object 1 and that are acting on object 1. Okay. One force which we may directly see is the weight of the object itself. Okay, because all the objects they exist on earth and earth pulls it down with a force. We'll say that the force of attraction W1 is one force which is acting on object 1. Similarly, if you see, this object 2 is touching object 1. So this object 2 will exert a force as shown here. Okay. So let us try to show that same force here. You have this force. This force is represented by F21. Okay. The subscripts are chosen to indicate the fact that this force is the force exerted by object 2 on object 1. Similarly, if you consider object 3, you have object 3 is trying to push onto object 1 with a force shown there. So we'll try to show a force here. Okay. This force will represent as F31 to indicate that this is the force exerted by object 3 on object 1. Okay. When once you isolate object 1 and represent all the forces which are exerted by other objects onto object 1, we call that as free body diagram. So what we have drawn here is free body diagram of object 1. Whatever information you can infer from the diagram of the system, all the details are available in this free body diagram of object 1. Now whatever analysis we have to do, be it equilibrium analysis or the task of finding what are these forces F21 and F31, you can perform it for this diagram. So in a way what we are doing is the entire problem of solving for this whole system, we are trying to break it into pieces and we are focusing our attention on object 1 in one case, object 2 as a separate case, and object 3 as a separate case by drawing free body diagrams of object 1, object 2 and object 3. Often this term free body diagram is abbreviated as FBD. Okay, the first letters F, B and D. Okay, let us quickly try to draw free body diagram of object 2. Okay, if we want to draw the free body diagram of object 2, show object 2 and then show all the forces which are acting on object 2 due to the presence of other objects. For example, object 1 is pushing onto object 2 with a force shown here. So we'll try to show a force, and this force we will call F12, force exerted by object 1 on object 2. Similarly, you have object 3 pushing on to object 2 as shown here. Okay, so we'll try to show a force here and say this is F32 to indicate force exerted by 3 on 2. And obviously we have the third force, which is the weight of object 2. Okay, we can find out the unknown forces from here. You can note one thing. This is force F12. This is force F21. By Newton's third law, this forms action, this forms reaction. They are equal and opposite. So we can note that F21 is equal to F12. Similarly, you can say F13 is equal to F31. F23 is equal to F32. We may use these to progressively solve for unknowns in a system. For completeness, let us try to draw free body diagram of object 3. You will draw object 3, okay, and note down what are all the forces that are acting on object 3. This is one force which we call F13. To indicate force exerted by body 1 on body 3, and this is another force F23. Okay, let us quickly show it. Obviously, the third force is the weight of object 3. Okay, so when we say free body diagram, we are trying to focus our attention on a single body or a group of bodies in the system, and then try to identify the forces acting on that object or that group of objects. To make that matter clear, let us try to draw free body diagram of objects 2 and 3 put together. Now our system is a combination of two objects. This is object 2 and this is object 3. Okay, now we have to find out all the forces, external forces that are acting on it. You have one force F12, you have another force F13. Okay, you can see that these are the forces which are coming here. F12 is this force, F13 is this force. Okay, and then you will have gravity force of object 2, and you have gravity force of object 3. Note carefully, we are not indicating these two forces, the forces in between them, because they will anyway cancel out, and they can be removed by law of superposition. Okay. Now in engineering systems we may have objects getting in touch with each other in different ways. Okay, those we will quickly see. Okay, there are 3 columns here. One is type of object affecting the free body, schematic representation, and free body diagram. Okay, if this were to be the free body, we'll show the effect of Earth by an arrow as shown here. That arrow is coming from the center of gravity of the object, and that we call as weight of the body. Quite often we don't even show this Earth because we already know. Just for the sake of completeness, I have shown it here. When you have an object supported by a flexible cable or flexible cord or flexible rope, okay, we have the free body diagram representation this way. We have weight of the body acting down and the tension in the rope going up. Okay, going up or in whichever direction that rope is. If you have an object supported by an inclined rope, the tension will be inclined and directed along the direction of the rope. So this is what we call a rope. Okay, wherever you see a rope, you have to put a tension in the rope as a force acting on the body, and this direction goes along the direction in which the rope is running. When you have a smooth inclined plane touching the object, if this were to be the free body, that is the object for which we are trying to draw the free body diagram, which is touching an inclined plane making an angle theta. To draw the free body diagram of this object, you will remove the inclined plane as shown here. The inclined plane does not appear here. While drawing free body diagram, supports do not appear on the free body diagram. And this is the normal force N. This force is perpendicular to the inclined plane. So if this were to be the force N, this N will be perpendicular to the inclined plane. Similarly, when you see a hinge, by a hinge I mean it's a connection similar to the one you have between the door and the wall. Okay, a hinge allows only pure rotation. If such is the case, then on free body diagram you will show 2 reactions, Fx and Fy, as shown here at right angles. Similarly, for ball and socket joint, which is a 3 degree of freedom spherical joint, similar to the one we have at our shoulder between hands and torso. If that be the case of the joint, you will represent it this way as shown here, and you have 3 reactions, Fx, Fy and Fz. By a roller support we mean a support which is very smooth, frictionless. If the roller support is on a horizontal surface, you have the reaction going vertical. If it's an incline, as shown here in this case, okay, you have the reaction N going at an angle theta to the vertical. And finally, if it's a curved surface touching our free body, that is the object on which we are focusing our attention, the force will be normal to the curve at the point of contact. I don't expect you to remember all these, but when we are solving problems, we will be coming across situations which are similar to one of these shown, one or more of these shown, and we'll gradually try to learn how to draw free body diagrams. In subsequent lessons, we'll try to see several problems on how to draw free body diagrams and solve problems in engineering mechanics. With that, we conclude this lesson.